Have you ever wondered about the dangers that spacecraft face when re-entering Earth's atmosphere? Picture this. A spacecraft is returning from the moon, moving at a speed of over 11 kilometers per second. That's a lot of kinetic energy to dissipate. In fact, each kilogram of the spacecraft has about 60 megajoules of energy, which is 15 times the energy content of TNT. This energy makes the air around the spacecraft glow brightly as it re-enters the Earth's atmosphere. It's a good thing that the air is what's glowing because it means that the spacecraft is dumping its excess energy into the air rather than into its contents, which in future missions will include people. What keeps the spacecraft from burning up is a large ablative heat shield. But with such inherent dangers, you might ask, isn't there a way to avoid this? Can't we slow the spacecraft down so that it doesn't have to handle this amount of energy? Or perhaps use a winged vehicle like a space shuttle to stay high above the dense atmosphere until it slows down. Let's delve into the physics of re-entry and why it's not as simple as slowing down the spacecraft or using winged vehicles. To understand why spacecraft can't simply slow down to avoid the hazards of re-entry, we need to understand the rocket equation. The rocket equation, it's a fundamental principle of space travel, and it's the reason why we can't just slow our spacecraft down to a crawl before re-entry. You see, any change in speed in space requires fuel. The more speed we want to shed, the more fuel we need. Let's say we're in orbit, moving at about 7.5 kilometers per second. If we want to slow down by 5 kilometers per second, that would take a significant amount of fuel, and it's just not practical. We're not just talking about a little extra gas here. To slow down that much, we'd need a whopping amount of fuel roughly equivalent to the entire initial mass of the spacecraft, and that's just to slow down. We haven't even talked about the fuel needed to get back to Earth yet. Now what about winged vehicles? Couldn't we use wings to glide through the atmosphere, staying high above the densest parts while we slow down? Well, it's a nice idea, but it's not as simple as it might seem. Wings work by creating lift, and lift requires air. The higher you go, the thinner the air, and the less lift you have. So, to stay high above the dense atmosphere while slowing down, you'd need a massive wingspan and a very lightweight vehicle. It's not impossible, but it's far from practical, and it comes with its own set of challenges. As we can see, the laws of physics make it challenging to avoid the intense heat and energy of re-entry. So why must spacecraft endure the hazards of re-entry? This is a question that leads us to the heart of the matter. The answer lies in the very physics that govern our universe and the engineering challenges that come with it. Throughout this video, we've talked about the immense energy a spacecraft has to dissipate upon re-entry. It's a spectacle of light and sound, but it's also a testament to the sheer force at play. Each kilogram of the spacecraft holds about 60 megajoules of energy. That's 15 times the energy content of TNT. Imagine trying to safely dissipate that kind of energy. It's a mammoth task, but one that's crucial to the survival of the spacecraft and its precious cargo. And then, there's the rocket equation. The concept may sound complex, but it boils down to this. Slowing down a spacecraft in orbit to lower its speed upon re-entry isn't as easy as hitting the brakes on your car. It's about fighting against gravity and momentum, and that requires a tremendous amount of energy and resources. In simple terms, it's not currently feasible with our existing technology and understanding of physics. However, that's not to say we're at a standstill. Engineers and scientists worldwide are constantly working on ways to mitigate these risks. From improving heat shield technology to exploring innovative methods of energy dissipation, the quest for safer, more efficient re-entry is ongoing. Despite the challenges, the exploration of space continues, fueled by our insatiable curiosity and the relentless pursuit of knowledge. The hazards of re-entry are just one of the many obstacles we face in our journey to the stars. But as history has shown us, no challenge is too great when it comes to expanding the frontiers of human understanding and achievement.